Welcome everybody. We got an interesting question. We have this equation e raised to the power of 2 times integral 1 to infinity ln x divided by x squared times dx is equal to e raised to the power of t. We are expected to find the value of t. Now clearly this looks a little bit daunting because you have an integral expression which is featuring as an exponent for the left side. So foremost we need to sort that out. So what I'm going to do is I'm just going to start off by stating consider integral 1 to infinity ln x divided by x squared times dx. Now if you were to consider d of 1 over x, differentiating this is going to give me negative 1 over x squared, but I have a positive value. So if I were to multiply this by negative sign, then I would get a positive value. So I can rewrite this as integral 1 to infinity ln of x times, I need to produce this 1 over x squared. So to produce a 1 over x squared, I need to have a negative sign there followed by d of 1 over x. Of course, when you differentiate this, I need to place the differential operator. So the differential operator is placed. So that would mean if I were to differentiate negative d of 1 over x, I would be producing 1 over x squared times dx. Fine. Now you may be wondering why am I writing it like this. So that has got a reason. So this can be rewritten as negative 1 to infinity ln x d of 1 over x. Now this is similar to integral u dv, which is equal to uv minus integral v du. So in place of u, I got ln x. In place of v, I've got 1 over x. Now you can simply, instead of saying v, you can simply say dv is equal to d of 1 over x. So if you were to integrate this, you get v is equal to 1 over x. So that's the same thing. Now utilize this formula and substitute the value. So just take the value of du. Du is equal to 1 over x times dx. Now substituting it, this is going to be u is ln x and my v is 1 over x. So I'm going to substitute 1 over x here. The limits are 1 to infinity. Negative integral, my v is 1 over x, my du is dx over x. So that's going to be x squared, right? So this is what we are getting. Now we will have to integrate this. So limits are 1 to infinity. I substitute the upper limit, 1 over infinity is 0. I substitute the lower limit, ln 1 is 0. So this goes off. So you have a negative sign there, and I am taking this as x to the power of negative 2 times dx. Okay, now you might be wondering, I have not considered this negative sign, but I will finally evaluate this value and then place in the negative sign. So don't be alarmed that I have not taken care of this negative sign. It's there in the corner of my mind. So this is equal to negative of, I integrate this x to the power of negative 2 positive 1 divided by negative 2 positive 1. Limits are 1 to infinity. Now this is going to give me negative of x to the power of negative 1 divided by negative 1. That's going to be 1 over x with a negative sign, which is going to be 1 over x. The limits are 1 to infinity. Now I substitute the upper limit, I get 1 over infinity. I substitute the lower limit, I get 1 over 1. So that is equal to negative 1. So 1 over infinity is 0. So that goes off. So I got a negative 1. Just for your understanding, I will say consider integral ln x d of 1 over x. So 1 to infinity. So this has produced me negative 1. take the value here, substitute here. So negative of negative 1 is equal to positive 1. So I have evaluated this value to be as positive 1. So take it over here and substitute it. So this is 2. Therefore 2 becomes e raised to the power of 2 times of 1 is equal to e raised to the power of t. So e raised to the power of t is equal to e squared. Now take ln both sides. So ln e power t is equal to ln e raised to the power of 2. Since ln a power b is equal to b times ln a from logarithm, and ln e is equal to 1 from logarithm, this is going to be t times ln e, 2 times ln e. Ln e can be removed, therefore t is equal to 2. So this is the solution for the question. Now this is a beautiful question. I hope you like this, and please like, share and subscribe to our channel until we meet again.